Hey everybody, happy, it's Tuesday, right? Yeah, happy Tuesday. Hope you're doing well. Let's see, we got a couple things on tap today. So we're going to move on to new content here, Chapter 9, all about classes. Now, classes are fantastic. They're a core principle of object-oriented programming, and it's a very different way to approach problems and as opposed to how we've been doing them so far. So it's really expanding our toolkit. Now, there's nothing in classes necessarily that we need. You can solve problems without them, but we like classes because they give us a more natural approach to solving problems with this object-oriented programming. And then it does add some reusability and some other really cool features, but you don't need them to solve problems. That's sort of the idea here. So we'll take a dive into classes, and we'll wrap that up on Thursday. And then we had a chat in lab yesterday, and it sounds like you folks would appreciate going over the lab. So I'm definitely open to doing that. So we're going to start off talking about lab 5, I believe. That was our functions lab. So we're a little bit behind on that because that was a functions lab, but that one wasn't due till yesterday. So we'll talk about that functions lab, and then we'll get into classes, and then we'll try and pick up the lab that was due on Monday on the Tuesday after to give you a chance to go over some of those and look at how I might approach solving some of them, if that makes sense. So let me fire up PyCharm here, and we'll pull up that lab. And then I do need to apologize. I'm behind on grading stuff. I had my grandmother's funeral last Thursday, and that sort of threw off the entire week. So I've not got a chance to grade that second project or the midterm yet. I'll be hopefully getting caught back up later in this week. I can get all those in for you as well. So sorry for the delay there, but I should be getting back on track this week. All right, let's take a peek here at that lab. Grab that. I don't need my other tabs open here, do I? Yep, so our functions lab. So with 3 functions, right, our percentage of values within X standard deviations given some list and deviations from the mean, like some number of deviations, 1 deviation, 2 deviation, right? That's the X standard deviations. So we can take advantage of some of the stuff we've done. Trouble man, yeah, she'd been sick for a while. Had been struggling with dementia or Alzheimer's, or I'm still really kind of fuzzy on the difference between the two, to be honest. But we just, we didn't know when it was going to be, so yeah, it was made for a long week, but it's all good now. So, all right. And some of you had actually found there's a statistics package, which is pretty handy for doing some of this stuff. But when I went through and scored the lab, some of you, I think, were a little confused. Let's call this lab 5 on. Oh, it's not empty. Do I have a lab 5 already? That's weird. I don't remember doing that. Maybe I showed something back in lab. This is what happens when you get fuzzy. And, let's see. Did we do a scrambled word? Did we do this one? I'm confused now. It was scramble, given a word and a skip. Oh, we did this one. Okay. Did maybe I did this one? I don't. Folks, I don't remember now. I'm sorry. I'm a little. Maybe I did this one. Did we already talk about scramble? Did we already talk about lab 5? And I'm just confused. I don't know. All right, so anyway, the standard deviation. So there's 2. Sorry, Bay. What is yeah? I'm confused already. So yeah, we already talked about it, or I'll just drink some more coffee here. Don't worry. Okay. Oh, I did go over part 2. Okay, so I didn't go over the other parts. Okay, so part 2 we did in the lab, right? When we met in person 3 weeks ago? Goodness, 2 weeks? Well, it wasn't 2 weeks ago because we had the midterm that week. Okay, yes, I think we talked about it a little bit in lab time. So if you weren't there, then you probably didn't see this. So we can talk about it now. I don't know, I already have this one going, so might as well. So we're just doing our little sanity check here, this idea that if you tell me a skip value, like skip every one character, like if you're taking every character, then you're not really skipping anything. So skip had to be 2 or more to say, take the first character, skip. Then, you know, we're skipping by 2. Skip as long as we win. So anything other than that, we're going to do just the word here, and then we're going to get the scrambled word, and then we're going to say, okay, the starting index then starts at index 0 and goes up to the skip value, but not including. So I think I must have been hungry because our word here was beef pot pie. Let me grab my pen. And so we said, okay, if our word was beef pot pie, that's a blank there, right? Pot pie. We have indexes 0, 1, 2, that's an F, not a T. Beet pot pie is probably not as tasty as beef pot pie, but maybe that's your thing. 7, 8, 9, and 10. Right? So if we're skipping every 2 letters, right, we would start here, and we would 1, 2, 3, 4, 5, take 5 letters. Right? And then we're going to go to the next location, and we're going to take every other letter. We're going to skip by 2, 2, 2, 2, and 2. And we'll get those letters. That's a skip 2, right? If we were going to skip by 3, we're going to start here, and then we'll start here, and then we'll start here. Right? Each time, skipping if we're going to skip 4, then we'll have 4 different starting positions. If we skip 5, we have 5 different starting positions. Right? So that first outer loop says, okay, let's start at this spot, and then let's start doing our skips. So we start with our outer loop, starting at 0, up to the skip. Then we're going to range from the start index up to the length of the word, right? Because remember, ranging to a length will give you up to, but not including that last index. There is no index 11 in beef pot pie. It's 11 characters. I have indexes 0 through 10. And we're going to use the skip value to say, in my range, this is my stride. I think we call it stride is the official term there, right? This is the amount that I'm going to jump each time. Hey, Holo, I can't say your name. I'm sorry. Fractal Fairy. Thanks for coming on by. So we're going to grab from the start index, right, which is either 0, 1, 2, whatever it happens to be, up to the length, going by skip. We're going to grab that letter, add it to our scrambled word. When we've grabbed every letter, skipping, then we go back and we go to the next starting index. So I did a range from 2 to 12, so this will start at 2 and go up to 11, and we can see once you hit 11, right, if your skip is longer than the word, well, we're never going to get anything other than the original beef pot pie back out. So you can kind of see there's like different levels of scrambling here that happen. This is every other, this is every third, every fourth, every fifth, sixth, seventh, eighth, ninth, 10th, 11, we get the original word back. So there's not a whole lot of scrambling that happens, right, with some of these. I like this one. The PE pot. I would not get beef pot pie out of that one, but again, maybe you're good at those sort of word scramble sort of things. And again, you can give it any length of word here, right? Any length of string and any amount of skip is perfectly fine. Okay, so that was the scramble portion here for fun. Now we're going to look at our function percentage of values within X standard deviations given some list and X deviations from the mean. So this is, okay, I got talking about standard deviation. So there's 2 types of standard deviations you can calculate, right? If you just go look at standard deviation and we look at our Wikipedia page, there's 2 values. There's a sample standard deviation, which is saying I only have a sampling of values from within a population, or there's the population standard deviation. A population standard deviation means you have all of everything you're calculating. And that's what we do have, right? The idea here in our lab was within this list, right? So the sum list is this is the population. So if you're using that statistics package, which is perfectly fine, right? The math part is not really what we're focused on. The focus was on, can we do these things? If you look up Python statistics library, you can just add in this statistics library. Where is it here? Module statistics, probably this one. This is not even a great, sure. Yeah, this is fine. And there's a couple different, there's the standard deviation from a sample of data, or there's the PSTDEV standard deviation. from an entire population. So if you were doing that, you should have been using the population standard deviation. I didn't take any points off, but I just kind of gave you a funny look. Like, well, why would you assume that was a sample if I gave you the entire list? So, because the formula is different, right? With a population standard deviation, you're dividing by n, because that's the population. With a sample standard deviation, you are, where is it in here? Sample. You're divided by n minus 1 is the difference here. So again, just a little statistics difference here, but it would change the values that you would end up here. But either way, right, if you wanted to do it yourself or not, if you wanted to import the library, great, but it's not too hard for us to calculate, right? So let's write our function. This is percentage of values within X standard deviations, given that and the number of deviations. I'm just going to copy that in, and that ought to work for us here. There we go. Define percentage of values within X standard deviations. So the first thing we had to do was get the standard deviation from the sum list. Excuse me. Right, so to calculate that, we needed to calculate the average. So our average, or really that's the mean, right? You'd call that, is the sum of some list divided by the length of some list. Right? Assuming it's numeric, right? Because if it's not, we can't really do anything with it otherwise. Got to go back to make sure I'm doing the right formula here, because I get confused easily. Right, so we take the average, and then we take the difference of that squared. Okay, and we're going to add all of those up, divide it by the length. Then we're going to take the square root of that, not beef pot pie. So we're going to then have the sum of differences, and squared, right, is going to start off at 0, and we'll say for value in some list, we'll have the difference squared is equal to the value minus the mean, right? Make sure we do this first. Squared times 2, right? Not times 2. I'm sorry, not times 2. Squared. So to the power, right? We can either use a double operator here, or just math.pow if you wanted, and we'll add that to the sum of differences squared. So plus equals the difference squared. When we're done, we've gone through every list, then we're going to take the sum of difference squared, and we're going to, actually, we'll just say, here's our standard deviation, right? We can just calculate right here. So standard deviation is going to be the sum of the differences squared divided by the length of some list, and we need the square root of that. We take all of that to the 0.5, right? 0.5, or, square root, math.square root. Either way, you want to do your square root here, right? So we sum them all up, divide by the length, take the square root to get our population standard deviation. Okay? Then we need to find out how many deviations from the mean we were looking at here. Right? So we're going to say my what total, I don't know, deviations from the mean, or there's a good term here I'm trying to think of. I don't know. Just total deviations from mean is the standard deviation times the deviations from the mean. Sure, we can call that total deviations. I don't know. That's not even, I don't know, x deviations. Sure. I don't know. That's not. I'm not even happy with this, but that's fine. That's some number of deviations, right? Then what we can do, right, we want to see, is the number plus or minus this, right, from the mean. No, I'm sorry. Is the number, the mean minus the number. Oh my goodness, math is hard, friends. Math is hard. So if my value, I don't know, we had like 2, 3, 4, 5, 6, 7, 8, and 9 or something, right? 1, that gives me 9. That's not what I want. I want 10, right? I can't even do math right now, friends. 5, 5, 5. Okay, that gives me an average of 5, right? So if I wanted some number of deviations from the mean, I'm going to take the mean value. I'm going to take the mean minus the value and see if that is greater than the mean minus my x deviations, right? And if it's less than, I guess, or equal to, right, the mean plus the x deviations, right, if it's between those two values. Now, someone else had a really good one. They used absolute value. And I don't remember where they put it here, and it's the math here is escaping me at the moment. But we can check. So we need a count of values within x deviations. We're going to start that off at 0, and then we're going to say for value in some list, we're going to do this loop again, right? Grabbing each value at a time. If the value is greater than or equal to, right? So it's my x deviations, or the mean minus x deviations, is less than or equal to the value, which is less than or equal to the mean plus the x deviations. We'll take my count of values plus 1. Right? And then when we're done, we're going to return that count of values divided by the length of some list. Right? This will give me the percentage of values within so many standard deviations. We calculate the standard deviation and then look at every value and see if we subtract that number of deviations, if it's between that and the mean plus that many deviations. Why can I not think of the absolute value version of this? That is, my head's hurting right now. Obviously needs more coffee. You took the mean minus the value, was that it? And then you could check for if that was less than the standard deviation or something. I forget what it was now. Don't remember. My algebra's lacking. All right, but that was our percentage of values within x standard deviations. Was the idea here. That one make sense? Well, this was our function. So to go back to the lab 4, where we were just practicing our loops to do the standard deviations, we could then use this function instead, because we were calculating percentage within 1, percentage within 2, percentage within 3. Right? Now again, this wouldn't actually be as efficient because it had to recalculate everything every time. So in terms of the code being efficient, it would make it easier for us to do the first part, but it just have to calculate the standard deviation every time. It would be slower to calculate those values every time. But, it's not too big of a deal. We're not too concerned about that because we're not dealing with millions of numbers or anything. So our sum list was small. Okay? And then the last lab here was our function menu given a list of options. We're going to display the list with, make sure it was at least 3 choices or something. Use a validation loop and return the choice. This display the list, saying when you do this, you probably want at least 3 choices here. So this was our function for menu. Find menu given a list of choices. We'll print the list of choices. I don't know, or we'll say pick one of. Pick one of. And then the list of choices. Sure. Or we can just comma separate those even, right? And then we need to get their input. So our input is going to be, the choice is going to be an input. But actually, really, we could just throw this in here then, right? Pick one of these. So when you're doing an input, you have to do the string concatenation. We can't use, oh my goodness, not even a colon. You can't use the comma separator, but we can say pick one of, and then we'll say, well, choice is not in the list of choices. Well, they can pick again. Right? So sure, make them pick again. And as long as it's not in that list, keep on going, keep on going, keep on going. And when we're done, we can return the choice. This is just making sure, this is our little validation loop, making sure that they give me something that was in that list. So if we're going to test it, right, we can make our menu, our choice could be a menu given a list of options, right? We could say, hey, how about you pick rock, you pick paper, or you pick scissors. Right? And we give that a run, not generate, no, a run. Oh, goodness. Can can't concatenate. So I'm sorry, a string of the list of choices. Sorry, we can explicitly tell it to turn it into a string. That's what we have to do inside of an input. There we go. All right, pick one of rock, paper, scissors. So if I say rock, it says, oh, that doesn't match because it's not an uppercase R, rock. Right, and we could just keep on going. You just got to keep on picking over and over and over and over again. That's all. I think would a formatted string work better for that? And then we don't have to do that as a string. I feel like we can do a formatted string. Give that a try. I'm curious now. I think the formatted string works better for this. Right, and then we can make it even prettier, right? Add like a colon after the or something. All right, let's give that a try. Yeah, our formatted strings are so much better than any of that. So rock, ASDF, right? If it's anything that's not exactly in that list, we just keep on asking and asking and asking. And that was our menu. So anytime we have a menu, right, we could kind of reuse that function that we've defined, and it should work for us. Okay, does that make sense? All right, cool. So I think we're good with the lab here. I think the little guy's looking for me. Give me 1 second. Let me throw some music back on. I got to take him back downstairs. He's got into my office. Let's play on this for you real quick. Alright, sorry about that. Once I took him downstairs, he wanted a little snack. We had to go pick one out real quick, so. Alright. So we're back. So we'll start out our classes project here. So this was classes. Now what's really cool about classes is it gives us a different way to think about how we write our code and how we use our code. So, like when we did stuff, when we like imported the math library, we said math dot, oh, that's a lowercase then, right? Import math. We said math dot. There's a whole bunch of these functions that just exist already. And the reason why they exist is because someone wrote a class called math and made them available to us. So one of the reasons we like this object-oriented approach is it lets us have these reusable libraries. You could do that with just functions, but we want to bundle them together into a related class. So everything that's math-related goes into the math package. If you were to import statistics, right, we could say statistics dot, and we could see these are all these statistic-related methods. So they let us put a nice kind of bundle things together into a related package. Now, the way we're going to use classes is going to be a little bit different with our object-oriented approach in that we're going to not have these functions that just work. I mean, you can do that sort of thing. We'll talk about that when we do modules next week. But for our purposes, a class is going to represent an object. And, you know, that's a physical object or something that we're used to. So generally, a class is a noun. And our nouns are people, places, or things. And what's cool about that is you might have a class like mug, right? And we know, because this is how people work and how we're used to interacting with things, is that just because it's a mug, every mug is different, right? So I've got this mug. It has a certain set of attributes. It has a color. It has the amount of liquid that it can hold. It actually has coffee. You can't see that right now. Coffee inside of it, right? So each mug that you have is going to have those different statistics. And then you look at a different mug, right? You can have another instance of that class, and it can be a different mug. Now this one's empty, right? There's no coffee left in this one, which is sad here, but it has a different color, a different shape, a different size, right? The whole different amount of coffee or other liquids, I suppose, you can put in mugs. Tea's not too bad. So we can have different instances of them, and what that lets us do is we can interact with them in memory, right? So they all have they have a similar list of attributes, right? So all mugs have a color, all mugs have a size, all mugs have an amount of liquid that are inside of them, and then we get to interact with it in memory. So we're going to define a class here. We're going to call it mug. So we say class mug. Then what we're going to do is we're going to define a special method here called the initializer, init here, or in other languages known as the constructor. So we're going to define underscore underscore init given self. So self is a special keyword here we're going to talk about as we get moving on. And self means the current instance. So I can have 10 different mugs, and I can probably find 10 different mugs around because I drink a lot of coffee and forget to take them downstairs sometimes. And every one of them will have its own set of attributes. So we say self dot. And self dot means, okay, this current instance, this instance, we're going to say has an attribute, and we're going to give it a list we're going to give it some values here. So I'm going to have attributes for like size. Starts off as empty. Self.color starts off as empty. And you know, size is kind of unspecific. So maybe we'll say size in milliliters. Right? And then maybe we'll say that one's 0. Did I misspell milliliters? Really? Milla? Are there 2 L's in milliliter? There we go. 2 L's in milliliters. Right? Its color is empty. There's no color until we know otherwise. And then we'll have a self dot, I don't know what, current volume of liquid in milliliters. Again, anytime you have a unit, right? Volume, why do I not know how to spell? If you just say volume or size, right, it's very ambiguous. And some people might think you mean ounces because you participate in the terrible unit, the measuring system we know as the imperial system, instead of the metric system, which is much superior. So you should be specific and say, okay, I mean the size in milliliters, or the amount of liquid in milliliters, right here. So anything we say self dot, is now an attribute of this instance of the class mug. And then what I can do now, I don't need to do anything else. I can make mugs. So I can say, here's my marathon mug, and to make one, we say mug, set of parentheses. This will call this init method here. So mug calling the init method creates the constructor for me here. More blank lines. Sure, have more blank lines. And then what I can do is I can say marathon mug dot, and I see now I have attributes for color, for size and attributes, and current volume and liquid. So I can set the color. Well, that one's white with blue edges. And I can say my marathon mug dot size in milliliters. You know, it probably holds 250 milliliters is my guess here. My marathon mug dot current volume of liquid in milliliters. It's probably down to maybe 50 milliliters. I don't have much left. Probably even less than that. Maybe only 25 milliliters. Not a lot. And this instance of mug now in memory has these attributes. And then I can make another mug. I had my, here we go, let's go with this one. I really do have too many mugs around my office, which is sad. Here's my chest bra mug. This one's gray. It's empty again, which is sad. Just says the coffee stain at the bottom. So I'll make another mug. So I'll say chest bra mug equals mug. And then I can take that chest bra mug and I can set the color attribute. Say that one's gray. Chest bra mug dot size in milliliters. Now this one's a little larger, I think. So this one probably holds like 300 milliliters. And then the current volume in liquid is 0. It's empty right now. So I have two different instances of the mug class. So a class you can think of like the blueprint for this is, it describes an object, right? And when you make an instance of it, it loads it into memory for you. So I can have multiple instances of mugs in memory. Okay? So right now, if we just say like print, it's not going to be very interesting. I can print my marathon mug, and I can print my chest bra mug. Oops. Print the chest bra mug. We can print them, and I'm going to get garbage out right now, which is kind of interesting. We see its main mug object at, here's memory address. So it tells me, hey, it loaded something into memory. That's where it is. So printing doesn't give you a whole lot of interesting information here. But the other cool thing you can do with classes is you can write functions that accept instances of the class. So I can have just a function built in here, like print mug, here, given a mug. And it can print the mug.color. It can print the mug.current volume of liquid. And it can print the mug.size in milliliters. Or maybe we even want to do that all in one line, right? Maybe we do that as a formatted string here. We'll print the mug current volume. So that number of milliliters, liters remaining out of, I don't know. Sure, we'll do another. That's getting a little long here. Sorry, we can bump that down a line. Sure, we can print that out. So we'll say, oops, parenthesis. You know, whatever the current volume of liquid is of milliliters remaining out of the max, right? Maybe we'll even do that. So F formatted string, color mug with, here, let's do it all in one line. Here we go, we'll put it all in one line. So then I can call, instead of print here, I can call my print mug function, given the mugs. And I'll get actual, like a nicer looking print value out. So white with blue edges, color mug with 225 milliliters of milliliters remaining out of 250. Gray color mug with 0 milliliters remaining out of 300. Sure. Anything we want to do in there. So we can write our own functions then, and we can pass objects to the function. So you can have an instance of a class that you're passing, and they all have these attributes because we've defined them in this init method here. So we have access to all of those attributes. Now this is actually a little bit bad form. We'll talk about some better object-oriented practices more on Thursday. We just kind of want to get some basics down now. Other cool things you can do with mugs. So like this is just a bunch of attributes. There's no real interaction happening with the mug. What we can do is we can have a method here we can define of the mug class. So if we have a method like fill, and now all the methods that deal with an instance of the class need self. Now, self is kind of a really funny attribute. It gets implicitly handed to the methods when you call them, which is really cool. But if I just say, hey, fill self, I can take my self dot current volume and I'll set it equal to my self dot size. We'll fill it up. So we can interact with these instance attributes or these values that belong to each instance. So if you fill a mug, I'll go say, okay, max yourself off. Or maybe we'll go down by 10. I don't know. You should always fill it up to the brim, right? Who cares if it splashes when you pick it up? We're making the rules here for our mugs. So we can say, oh, great. So we'll set my self current volume to the self size, the max. Okay, so then I can make these mugs, I can print them out, and then I can fill them. I can say marathon mug dot. And now I see there's a method here, like an M for method. I can say fill. So I take my instance and I fill it. What happens here when you call a instance function, one that has self here, it's actually implicitly getting handed to the mug class itself, which is kind of fun. And I take my chest bra mug and I can fill that one, and then we can print them again. So if I put this in debug mode, I'm going to put a little breakpoint here on fill. I'm going to run it in debug mode instead of regular mode. We can actually watch what's happening, which is really fun. There we go. So I'll see I have my chest bra mug. Here's some location in memory, and I can open it up and I can see I have a color, current volume, and a size. So if I step into, so I don't want to step over now, I want to step into my code here. That's the little down arrow with the little lines here. I'm going to step into the fill method. Now I see what is self. Well, self was the marathon mug, right? White with blue edges, currently had 25, max of 250. And we're going to see it's going to do this line of code. So then we can step. And now the marathon mug, the size and the current volume are equal. We've filled it up, right? We've interacted with that mug. So if I step, I can see my chest bra mug. I don't need to step in again, but we can step over. And we'll see now its size and current volume match. Right, the current volume now matches the total size, as we matched it here. So it will run the methods that you define, the functions that you defined, with this version of self, which is fun. So what's different, right, because all these have self, right, if I just say mug dot, I see fill here, but it wants a self. So it doesn't really make a lot of sense to call fill, because I didn't give it an instance of mug to fill. So if I try and just run this code here, I gotta stop and run. It's upset. It says, hey, we're missing a required positional argument, missing self. So what you can do if you really want is you can then hand it another mug, an instance of mug, that will be treated as the self. This is really kind of funny. Python's a little bit of a funny language as you can do stuff like this. So this is a weird way to write your methods, though, and this is not very object-oriented conventional. So all of our other languages that are object-oriented, you take your instance of the object and you call your method. Python sort of cheats and does this. So if you do this, it essentially translates it to this for you, because this is harder for us to write. It goes to the mug class and says, okay, do this code given this thing is the self. Whatever the thing is as the self is the instance that you asked for. Mug fill. Okay, so I don't know, we'll just say that's the awkward way to call the method. We should, let's put this up here. They both do the same thing, right? This line and this line do the same thing. This is the conventional way. This is the funny way you can write it in Python. So the idea with object-oriented programming is that we can write ways that we interact with these classes. So we can also write a define drink method given self, and then maybe how about a milliliters to drink. So we're going to take our self.current volume of liquid and we'll subtract the milliliters to drink. I'm sorry, minus equals, right? Take that away here. So you tell me how many milliliters you want to drink, I'll change my volume. So then we can interact with our mug, we can fill them up, and then maybe we'll take our marathon mug and we'll drink. And then in here I would say, hey, I want to drink 50 milliliters. And that's the milliliters to drink. Now this is another reason you want to name your variables really nice, because this little IntelliSense is telling you, hey, the value you're entering here is your number of milliliters to drink. So if we run this, we filled it up to 250, we drank 50, we have 200 left. right? I wish I could fill my mug that easily. Crunchy. Got a little coffee grounds in there. That's a bummer. Or maybe a bonus. So we have ways, these are public methods that we give people to interact with our current volume. Right? Now, this idea here, what we're doing with creating this class is this idea of encapsulation. So encapsulation is one of the fundamental principles of object-oriented programming. We're taking all the details and putting them into one nice little package about this noun, right? We're taking everything, all the attributes about mug, and we're putting it into a nice little package. We're giving you public methods that you can use to interact with it. This sort of goes hand in hand with the other idea of abstraction. You don't need to know how mug works to call the fill and drink method. You call fill, it does what it's advertised. It will fill it. You call drink, you tell me how many milliliters to drink, we'll drink from it. Right? The same way in that we don't know how input works. Right? When we ask for user input, we call input. You don't need to know how it works. We work with it abstractly. You don't need to know the details. So what people can do is you can write entire libraries of code. And this is why data science works, right? People have written libraries upon libraries upon libraries of code in Python, and you can just go call some methods and do data science stuff. And you know, sort of. You kind of need to know what it's doing, but you don't need to know how it's doing it necessarily, right? So there's all sorts of really cool libraries people build using this object-oriented approach that let us do cool things. And it's not even just data science stuff. I mean, Python can do all sorts of really cool things. You can do, you know, solve all sorts of problems in Python. It's a great language. But we build classes that people can interact with abstractly. You don't need to know the details. Now, one of the things you're supposed to do when it comes to object-oriented programming is you're supposed to hide the details. Right? That idea of encapsulation also means that you want to protect your class so someone doesn't come in and set a bunch of values like this. Because we have no control, right? They could set the current volume to like 1,000. And if your max size is 250 and they all of a sudden put the volume at 1,000, they've done a bad thing. Right? So we don't want to give control of our attributes directly to people. That's probably pretty bad, right? Because then they can put us in a bad state. So the idea of encapsulation is we also need to protect the integrity of our class. So if I say drink, if I were to drink 1,000 milliliters, we would go negative, right? We'd probably be in a bad state. So I'm going to do a quick little sanity check. I'm going to check my current volume and say, hey, if that's less than 0, let's put it back to 0. Self.current volume is 0. I'm going to maintain the integrity here of my class to make sure I never have a negative volume. Because you can't have a negative volume. That's impossible. Right? There's no way to have negative amount of coffee in my cup. You can have 0 coffee, yes, but you can't have negative coffee. So when we write our class, we need to protect the integrity of our variables. So to do that, there's a convention in Python that we are going to assume people do the right thing. So all of our attributes right now are considered public. Right? I just say something dot and I have access to them. It's a public variable. Other languages do this a little bit stronger and have better protections against it. Python just uses a convention and is trusty that people will do the right thing. What we're going to do is we're going to rename them to put an underscore in front. And any variable that has an underscore in front is considered a private variable that you shouldn't touch. So I'm going to right click, go to refactor, rename, and I'm going to put an underscore here. So underscore size in milliliters. We'll refactor that. Yes, refactor. Same with color. I'm going to refactor, rename, call it underscore color. Yes, refactor, rename. You don't want to do this by hand because we use this all over the place. So always use your tools for things like this. Refactor, rename. Great. So now they're all marked as private. And now you'll see, where is it here? Is it just because I'm doing it there? So right here, it's warning me access to a protected member color of a class. It's telling me, hey, you're doing a bad thing here. It still lets you do it because Python is trusty, but it essentially is telling you we did a bad thing. So what we want to do then is instead of having a method here that just accesses them directly, we want to give them public methods that give them access to those values. So I'm going to write some methods, or I can tell PyCharm to generate them for me. Can generate some, No, is it not going to do it? Okay, whatever. It's not going to do it. So generally you have these methods like get. So get will get a value here. So we can say get size in milliliters. Milliliters. And what we're going to do is we're going to return the value of self.size in milliliters. Oops, sorry, given self. There we go. So I can return my current size. Now remember, when we deal with functions, when we return values, we're returning copies, right? They're not going to be able to change this actual value because I'm giving them a copy here. When we deal with our integer values, and we deal with strings that are immutable, right? I can give you a copy of the string. We'll define a get color method given self that returns self.color. So inside the class, we have full access to these things that we're saying, hey, they're private, don't touch them. So don't touch them outside of the class is what that means. So we're going to control access to these, and then a get current volume. I'll just copy that because that's easier here. Get current volume of liquid in milliliters will return self.current volume of liquid in milliliters. Okay. Now again, our print is ugly here, but what we can do then, we can say mug.getColor. We can use the methods that are available here. Get current volume and get size. So these are public methods that we're giving people access to. We're saying, hey, use these public methods to interact with my class here, right? Now, again, we don't want to be setting them directly here either because that's kind of ugly. So we can either give them a method to set, or we can have them be arguments to init. I'm a big fan of having arguments to the init method. So when you create an instance of mug, right, you're going to tell me what the size is. Oh, sorry. Give me, oh no, that should be fine. That's an appointment reminder. You're going to say, hey, you need to tell me what your size is here. So we'll say, hey, you give me a size in milliliters. Milliliters. I can't type here. So I'll set the size in milliliters to that. And then how about you to even give me a color, right? And I'll set my color to the color you give me. Now, I don't know much about mugs, but I do know once the mug is a certain size, you're never going to be able to change that size, right? But you can paint a mug, right? If I get some paint, I can put paint on this, and I can change the color. So if I want to give someone access to change a value, what you do is you write a set method. We'll say set color given a color. And I'll say my self.color is equal to your color. Now, I'm going to assume when you make a brand new mug, it's empty, right? You don't have to have arguments for every attribute, right? It's fine to give an attribute a default value. Not a problem here. So when you make a mug then, right, I need to give it some value. So I need to give it the size, so that was 250, and white with blue edges. And then I don't need to give it a current volume either, right? So I can say this one was gray, or 300, and gray. I don't need to give it the size. So this is the init method here. So we're calling the init method. Let me put that over here. All the init method, or underscore init, right? We can run this one now. We get the same results out here, right? But now they only have access to the public methods. So, and PyCharm is really good about this. It actually is going to hide it. So if you have that marathon mug, you can say marathon mug dot. You'll see all those things that are private don't even show up in this list. Right? They are technically available because Python is trusty, right? There's no hard and fast rule that you can't have access to them. In other languages, like if you go learn C++ or Java or C# or a bunch of other languages, if you mark something as private, you actually cannot get access to it. Python is just going to trust that you don't go access it, but there still is a way to go do it because Python's trusty. And there's a different way to mark them as private that we just don't deal with in Python, which is fine. So you only see all the public methods. So you see you can drink, you can fill, right? You can get the size. Sure, all these things that we can do. Again, there's a bunch of other things in here. Don't worry about that. We'll talk about that in a couple of weeks when we get to inheritance. But we're giving people access to these methods abstractly. Right? They don't need to know the details, how drink or how fill works. They just need to know it will do the thing we told them it's going to do. Right? So we've encapsulated all the details about a mug into a class. We've protected our attributes. We made sure that we're going to be in a valid state. So you cannot physically make this current volume of liquid in milliliters more than the max, and you can't make it less than 0. Right? The only way you have public access to change it is by filling it, which sets it to max, and by drinking from it, which reduces it by no more than to 0. Right? The code itself makes sure that you can't get to less than 0. It's impossible. So we can still use methods here. Now the other cool thing you can do is you can define a method here like printMug inside the class that takes self. Instead of having your own method, right? We could give access to one, so then it's just self dot. And we could even use the methods. Right? Nothing wrong with using our own methods here. It's perfectly fine. Or we could just have direct access to them. Either way is fine. Not a big deal here. So then instead of printMug, we could say marathon mug, right? Or we could use our own printMug method and hand it the chessbrah right? Either will do the same thing because it's the same code, right? One now belongs to the class here and will print its values. One belongs to the rest of our code. It's not attached to the class here, is all. We'll still get the same output. That's the idea with classes here. So we've encapsulated all of our details into one nice little package. We are giving you an abstract way to interact with us through our public methods, right? That's what we're telling you can go use. You can use these methods here. There's publicly available methods you can go have access to. Go ahead and use them. And we're protecting the integrity of our class, right? Through, that's another point reminder. My goodness. Kids are busy. So encapsulation and abstraction kind of go hand in hand, right? As we make our class, we're taking all the details, putting them into a little package here, protecting the integrity of our class, and giving you this abstract public methods here. You might hear of them as a application programming interface or an API. Right? The things that you can do are the API. That's the way that you can interact with the code. That's its interface. That's how the code now interacts with mug. Mug.something, mug.something, right? Our mug do something, right? Or mine's a chessbrah mug. So chessbrah mug.something, right? We can interact with it, fill it, we can drink from it, we can do all those things. So our chessbrah mug, let's see, make sure it works, right? We're going to call drink, and let's try and drink like 10,000, right? It should put it down to 0, but not less than 0, right? Here's my gray mug with 0 milliliters remaining, right? The code is protecting the integrity, making sure you can't put it in a bad state. That's really important. You don't want to let your object get into a bad state. If it shouldn't happen, don't let it happen. We've got full control over that here now, which is super cool. All right, so again, there's nothing that we've done here that we couldn't have done without classes, but what it lets us do is it gives us this new tool so we can put all the code together into a nice little package, give public methods here without having to pass a bunch of stuff. So the other really cool thing, right, instead of having a list of here's the size, here's the color, here's the current volume, I just have an instance of mug. I said, hey, go make a mug in memory. Now I have this marathon mug and I can do anything I want with in here, in memory. And I have access to it and I can go use it. Right? So it lets me kind of put all these details together into a single instance and a single variable name and deal with it. So it's just so much nicer than trying to do a bunch of dictionaries, right? A dictionary of dictionaries that have attributes and things. That's just ugly, right? We have a class now with a bunch of, and you can have as many attributes as you want. Right? You could have 10, you could have 100, you could have 1. It doesn't really matter, right? You just have, here's all my different values. This is what they're going to be. Aha, my Dexcom is on. I can actually see what my sugar is again. That's low. Oh, good. My sugar is happy. Check that out. I love this little tool. Sugar is 121. That's like 1 point above where I'd like to be. So I should be between 80 and 120 is a sort of the goal here. This technology is amazing. I do like technology. All right. Questions, thoughts, concerns? We're going to pick it back up on Thursday. We'll talk more about classes, and we'll look at testing our classes as well on Thursday. Like right now, yeah, we did a bunch of things. We called a bunch of methods, and we kind of eyeballed it and said, okay, I expected this value here. Is that what I actually printed on the screen? We'll look at a better way to do that come Thursday. Hey, thanks so much for following along. All right, I think we're good to call it a day then. We'll come back on Thursday again. We'll finish this off on classes, and then we'll have a lab to practice the following Monday, and we'll just keep on going. We are hitting near the end of the semester, believe it or not, already. Don't forget your third project we're working on. Yeah, no problem, Jerry. They're also all out on YouTube. I export them all out to YouTube if you want to watch them there, because I know they do get taken down off of Twitch eventually. Oh, a dad joke you got. I just got a couple good ones here. Just got a couple good ones today. Oh, hang on, where is it? I screenshot them all to my phone every time I find a good one here. Where'd it go? So, you always get, good advice from people, and they say, the sky's the limit. But turns out, if you work at NASA, that's not a very good saying to have. A certain title, Trump man. So actually, the university administration does not allow me to use the title professor. I'm not a doctor. My official title is a LEO lecturer. Currently lecturer 2. They attach certain numbers to things, which is sort of funny. It can be 1, 2, 3, or 4. So I'm a lecturer 2. But lecturer Charnesky is a really big mouthful, so I'm perfectly happy with Eric. If you like Mr. Eric, Mr. Charnesky, that's all fine. If you want to be fancy, lecturer Eric, lecturer Charnesky, that's all great as well. But I'm more than happy with Eric. That works out well for me, and then makes me feel young, right? When everyone starts calling me Mr., makes me feel old. And Mr. Charnesky, like, oh no, that's my dad. I guess it's okay to feel a little old. I am 34, but that's fine. Yeah, no, definitely. And anything's fine. I just give people a hard time if they call me professor or doctor. Like, no, I'm not. Especially if you're applying for grad school or like currently in grad school and you just spam the all faculty list. You're like, hey, I want to do research for you. I know you have no idea about me if you call me Dr. Charnesky. And those people just make me sad. Like, you're in grad school. You should know a little better than to just spam people. I mean, it's a decent assumption to assume most faculty members have their doctorate, but I don't. And all of our tenure track faculty who are allowed to use the professor title all have their doctorate degree. But to be a lecturer, you only need a master's or higher if you're teaching undergrad. If you're teaching at the graduate level, you need a doctorate level education. You have to have like one higher than what you're teaching, essentially. But you can teach undergrads with just a master's degree. So when people are like, oh, hey, I'm a new master's student and interested in working with you, can I be a research assistant or something? And like, I'm not a doctor. You obviously did no research at all, and that's really embarrassing, and you should feel bad about yourself. So that's just a pro tip for you. Just do some work. It's embarrassing. So, all right, yeah. So we'll call it a day, and we'll pick it more up on Thursday. The exceptions and modules is actually a little bit light, and I do have a conflict on the 9th. I won't be able to do class on the 9th, but when we get a little closer to that, I'll post a notice here. But we can take care of all of that on 11/11, no problem. They're both real short chapters here. And next semester, we're going to do more with exceptions. So I just want to kind of introduce the topic, show you how to make your program not crash, and then we'll go from there, which is awesome. And modules is super fast. And then the week after that, we'll pick up files and talk about our final project for the semester. This is where we were going here. So we're doing the third individual project, and on 11/18, we'll pick up the final project, which again makes up 25% of your overall score here. So that's a big portion of your final score comes from that final project we're going to work on, starting on 11/18, and then again we'll present over a little synchronous Zoom session here on 12/13. We should have a lot of fun with that. Instead of a final exam, we can just present our projects and hopefully have a little bit of fun with that. So, all right. Any other questions, thoughts, or concerns? You folks doing all right? And reach out, let me know. Happy to meet with you, talk with you. You got all my contact info, so we can go from there. Let me put on my ending screen here, and then we'll see if there's anyone around we can raid for fun. I don't know who's online. We'll see. Is he on or just he's not streaming, right? No. Who's actually streaming? We've done chemistry. We've done... Oh, bother. Yeah, I guess there's no one else around who's streaming. So we'll just call it a day. We'll go from there. You folks take care. Let me know what I can do to help.